Line of Best Fit, Algebra 1 EOI Review. This is the last lesson for the Algebra 1 EOI review. It's over Standard 3, Data Analysis, Probability, and Statistics, and it's over Objective 2, which is Line of Best Fit. A line of best fit is an equation of a line that is close to the points of a scatter plot. A good equation will have about half the points above the line and half the points below the line, and will be increasing or decreasing at about the same rate. So when we have a scatter plot, we're going to have three different types of scatter plots that we could see. We could see a scatter plot that has no correlation, or the points don't really come together to be creating like a positive slope or a negative slope, if you could imagine drawing a line through them. The second type would be a positive correlation, which would mean that if you were to draw a line through the points, you would have something close to a line with a positive slope. And a negative correlation is very similar, only now we would have a line with a negative slope. If you look at this graph, this scatter plot first, you'll notice that what I mean by correlation. If you notice these points kind of come together to form what would seem like a line with a positive slope. So this says which equation best represents the line of best fit for this scatter plot. The easiest way to go about doing this problem is just by graphing each one of our choices and choosing the one that is going to be best fit this scatter plot given. So A gives us the equation y equals 4x minus 4. I'm going to go ahead and plot that line in blue. If you notice, this line is increasing at a faster rate than my scatter plot is seeming to increase, so A is not going to be my line of best fit. If you notice B has the same slope, it's probably not going to work either, but let's just go ahead and graph it. And like we thought, since it has the same slope as answer choice A, it too is increasing at too fast of a rate. If you look at C, it's y equals x minus 4. Go ahead and graph that line. Notice this line is increasing at about the same rate as my scatter plot seems to be increasing. It has about half the lines above the line, half the points above the line, and about half the points below the line. So this line does look like it could be my line of best fit. I'm going to go ahead and try D just to be sure. When we graph the line y equals x minus 2, notice that, again, it seems to be increasing at the correct rate. I mean, it does have the same slope as C, but this time it's intersecting the y-axis a little bit too high. All of my points are below, so D is not going to be my line of best fit. C is my best answer choice here. This next example says, Jane recorded the scores she received on tests compared with the number of hours she watched television on the nights before the test. What does the scatter plot imply about the relationship between her test scores and the number of hours of television she watched the night before the test? A says Jane's grades are going down. We can't tell that Jane's grades are going down because we don't know when these tests were taken. They might not have been taken in order. And so we can't say that they're necessarily going down or going up. We just know that this is showing the relationship between how many hours of TV she watched and what she made on the test. B says Jane will never watch more than 4 hours of television. Well, in the scatter plot, she didn't watch more than 4 hours of television, but that doesn't mean that Jane will never watch more than 4 hours of television, so we can't conclude B. C says getting higher grades will cause Jane to watch less TV. Getting higher grades is not going to cause her to watch less TV. It might actually be the opposite, that watching less TV is going to cause Jane to make higher grades. And then D says Jane's lower grades tend to follow nights where she watched more television. This scatter plot most definitely shows that relationship. When she watched 0 hours of TV, it looks like she got about a 98 or a 99 on her test. When she watched 4 hours of TV, she got close to a 60 on the test. So we can definitely say that Jane's lower grades tend to follow nights where she watched more television, D. This last example says Tamara recorded the population of Medville for certain years in this table. She determined the line of best fit that models this data is y equals 18x plus 1,520, where x represents the number of years since 1985 and y represents the population. According to Tamara's model, what is the best prediction for the population of Medville in 1997? This tells us that x is going to represent the number of years since 1985. We're trying to find the population in 1997. So from 1985 to 1997, 12 years have passed. So we're going to plug in x. We're going to plug in 12 for x because 12 would be the number of years since 1985 in the year 1997. So I'm just going to take y equals 18x plus 1,520 and plug in 12, which will give me y equals 18 times 12 plus 1,520. Well, 18 times 12 is 216, so y equals 216 plus 1,520. Add them together and you get y equals 1,736. So my answer here is going to be C.